In this video, we're going to go over how to solve quadratics using splitting the middle term. So the first quadratic we're going to try and solve is this one here. X squared minus x minus 72 equals 0. Whenever we solve a quadratic, particularly something like this here, we need to recognize that there are two types. We can have either a monic quadratic or a non-monic quadratic. And there are two separate rules that we want to use in both of these here. A monic quadratic will be in the general form of 0 equals to x squared plus bx plus c. So that means the value of x squared is 1. That's why mono, it's monic, because it's 1 as the a term. But if it's non-monic, that means the value for the coefficient of x squared is non-monic. That means it's not 1. So it's ax squared plus bx plus c. So we'll be going through these two examples here. We'll be going through different sorts of quadratics of these calibers here. So let's have a look at the first example here. X squared, take away x, take away 72. To complete the square, to split the middle term for a quadratic that looks like this, we need to find two numbers that adds to the b term, but timeses to the c term. So first off, I have a monic quadratic that's in the form x squared plus bx plus c. So if I have it like this, we need to find two numbers that add to b, but then multiply to c. And what are the values of b and c in this quadratic? Well, the value of b is just the coefficient of x, which is minus 1. And the value of c is simply the constant, which in this case is minus 72. Can you think of two numbers that add to minus 1 but times to minus 72? They won't always be this hard, but if you want to find an easy way to work out your two numbers, here is the trick. Look at the constant. The constant here is minus 72. And I'm going to write down literally every single factor of minus 72, but the positive versions, just to make my life easy. So I can say that 1 and 72 are factors of minus 72. I can say that 2 and 36 are. I can say that 3 and 24 are. I can say that 4 and 18 are. 5 is not. 6 and 12 is. 7 is not. 8 is 8 times 9. And there we go. Those are all the factors I can think of. Can you think of any combination of these two numbers here? So two numbers, two numbers, two numbers. Any combinations of them, the positive versions of them or the negative versions, which allow you to make them equal to minus 1. Okay, so when you add those two numbers, they have to equal to minus 1. Well, I can. The last two pair here. If I were to look at the last pair here, we can say that minus 8 times 9 is the same as minus 72, so that checks out. But then minus 8 plus 9 equals to 1. But we want it to equal to minus 1. So all we do in this case is we flip the negative from the 8 here to the 9. So rather than being minus 8 and 9, we can say it's 8 and minus 9. So 8 times minus 9 is simply equal to minus 72. That still works. But then 8 minus 9 is equal to minus 1. And ta-da, we found our two numbers. So now that we have our two numbers, 8 and minus 9, we can simply factorize this quadratic as x take away 9 and x plus 8. And that equals to 0. And the reason we know it's these two numbers is because minus 9 plus 8 was minus 1. So we worked out our two numbers. Now we can use another rule, which is called the null factor law. Null factor law says if you have two functions that are times to each other, that means either this function must equal to 0 or this function must equal to 0. And the reason for that is the only way you can get to 0 through multiplication is by timesing by 0. Okay? For example, if this number was equal to 6, we do not need to say this number has to be equal to 6 or this number could equal to 6. In fact, we could just say this bracket could equal to 3 and this bracket could equal to 2. 3 times 2 still equals to 6. But 0 is the only special case where either fraction must be equal to 0. So if we solve for this fraction here, this quadratic I mean, we can say that x minus 9 equals to 0. And if we solve for this, that means x is equal to 9. So that's this first bracket done. And the second bracket, we can say x plus 8 must be equal to 0, in which case x equals minus 8. And those are your two values for this quadratic. That's how you solve a monic quadratic using splitting the middle term. Let's work on another example, this time also monic. We're going to work out how to solve the quadratic x squared minus 6x plus 8. Can you think of two numbers in this instance that add to minus 6 but then multiply to 8? Well, I definitely can. I can think of the two numbers minus 4 and minus 2. If you're having trouble, you can always just list out the factors of 8. So I can say 1 and 8 are factors, 2 and 4 are factors, and that's pretty much it. But I can recognize that if I do 4 and 2, I can recognize 2 plus 4 is equal to 8. But let's say this number instead was equal to positive 6. We can say that minus 2 and minus 4, well, that's equal to minus 6, but then 2 plus 4 is equal to positive 6. But anyways, we found our two numbers. So if we found our two numbers, we can easily just factorize this quadratic as x minus 4, x minus 2, and that equals to 0. And again, we can use the null factor law to state that x take 4 must equal to 0, in which case x is equal to 4, or that x minus 2 equals to 0, in which case x equals to 2. Those are your two solutions. Let's keep going. We're also going to solve this quadratic here. X squared minus 8x minus 33 equals to 0. To solve this quadratic here, we need to work out two numbers that will add to minus 8, but then multiply to minus 33. And the two numbers that I can think of here are simply 11 and minus 3. Again, you can list out all the factors and work it out by hand if you're struggling with this. So now that we have our two numbers, let's just factorize this quadratic here. We can factorize this quadratic as x minus 11, x plus 3. And the reason we know it's this here is because minus 11 and 3 were our two numbers. Those were what multiplied to minus 33, but then also added to minus 8. And we can use the null factor rule. X minus 11 is equal to 0, in which case x equals to 11. And then x plus 3 equals to 0, in which case x is equal to minus 3. Those are your two solutions. One more example. We're going to do x squared minus away 5x minus away 24 equals to 0. Can you think of two numbers which add to minus 5, but then multiply to minus 24? This one's a little bit trickier, but there are two numbers, and the two numbers that I can think of are simply minus 8 and 3. Minus 8 plus 3 is equal to minus 5. Minus 8 times 3 is equal to minus 24. And again, you can simply just list out all the factors of 24 to work out what your two numbers are. So now that we have them, let us simply just factorize. We can factorize this entire quadratic by saying it's x minus 8, x plus 3. And the minus 8 came from minus 8, and the 3 came from 3. To solve for this, we use the null factor law. X minus 8 equals to 0. That means x equals to 8. Then we can say x plus 3 equals to 0, in which case x equals minus 3. And that's how you solve a monic quadratic. But what happens if you don't have a monic quadratic? Now it gets exponentially more difficult, but it's still doable. It's still pretty simple. So we're going to focus on this one here. 2x squared plus 5x plus 3. This equals to 0. In this case, we do not do the following. We find two numbers that add to 5, but then multiply to 3. We do not do that. What we would do instead is we have to worry about the value of a. The value of a comes into play here. If we have a quadratic that is in the form of 0 equals to ax squared plus bx plus c, where in this case a does not equal to 1, we need to find two numbers which add to b. That still hasn't changed. We still need to find two numbers that add to b. But then we need to find two numbers that multiply to not just c, but multiplies to the product of a times c. So the value of a is very, very important in this case. So let's look at this non-monic quadratic here. In this non-monic quadratic here, we need to work out two numbers that not only add to 5, but two numbers which multiply to 3 times 2. And in this case, 3 times 2, because value of c is 3, value of a is 2. So we need two numbers which multiply to 6. The two numbers that I can think of are 3 and 2. 3 times 2 is 6, 3 plus 2 is 5. So here's where this technique is actually named splitting the middle term. We're going to split this middle term as the sum of 3 and 2. And what that looks like is as the follows. 2x squared, rather than saying plus 5x, I'm going to say plus 2x plus 3x plus 3. And that equals to 0. And the reason I've split it is because my two numbers were 3 and 2. That means I'm going to split 5x in terms of 2 and 3, which were what my two numbers were. That's where that came from. So now all we have to do, factorize this quadratic. And we're going to split it up into pairs of 2. So we're going to split it up as this pair, and we're going to split it up as this pair. If we look at the first two terms, what can you factorize? We can factorize a 2x. And what we'd be left with is x from the first term and a 1 from the second term. We can factorize a 1. Then what can we factorize from the next two terms? We can factorize out a 3, so I'm going to say plus 3. And then in brackets, I'll be left with x plus 1. Now looking at this, what can we factorize between these two here? Well, I can see clearly we can factorize an x plus 1. X plus 1 is what's common. And what do we have left over? Well, from here, we simply have the 2x left over. So I'm going to write 2x. And from this term here, I have the 3 left over. So I'm going to write plus 3. So now we can use the null factor law to solve these two brackets here. We can say x plus 1 is equal to 0, in which case x is equal to minus 1. Or 2x plus 3 is equal to 0. And to solve for this, we say 2x is equal to minus 3. That means x is equal to minus 3 over 2. Those are your two solutions for this non-monic quadratic. Let's solve another one. In this one, we're going to be solving 4x squared minus 8x plus 3. That equals to 0. Go ahead and solve this by yourself. So what are the two numbers that we're looking for? We need them to add to what and multiply to what? Well, we need them to add to the b term, so add to minus 8, but then multiply to 4 times 3. And in this case, 4 times 3 is just 12. Can you think of two numbers that satisfy this criteria? Well, I can. That would simply just be minus 6 and minus 2. And again, if you're struggling to find these two numbers, list out all your factors of 12. You will surely get it if you list them out and search for which combination of numbers add to minus 8 and multiply to 12. So now we know it's these two numbers. Let us split this middle term. So it goes from minus 8x to the following. So we can rewrite this quadratic as 4x squared minus away 6x minus away 2x plus 3 equals to 0. The reason I've written it like that is because minus 8x, you can split that up as minus 6x minus 6 minus 2x minus 2. Now we do the same thing. We group them up into pairs. What can you factorize from 2x squared and minus 6x? Well, I can factorize out a 2 as well as an x. From the first term, if I divide by 2x, all I'm left with is a 2 as well as an x. And then from here, I can factorize out a minus 3. Now from the next two terms, I can't really factorize anything, to be honest. So I'm just going to factorize out a minus 1. So if I factorize out by minus 1, I'm left with 2x, take away 3. And that equals to 0. The reason I'm factorized out a minus 1, by the way, is because I want these two brackets to contain the exact same thing. If these two brackets contain the same thing, that means I can factorize them. What am I left with from this first set of numbers? I'm left with a 2x if I factorize out the 2x take 3. So I can write 2x in here. And what am I left with if I factorize out the 2x take 3 from here? Well, I'm left with minus 1. Minus 1 equals to 0. So now we can say that 2x take 3 is equal to 0. That means 2x equals 3 and x equals to 3 over 2. Or 2x take 1 equals to 0, in which case 2x equals to 1 and x equals to a half. And these are your two solutions right here. Next solution, next question. We're going to work out how to solve this function here. Pause the video and give it a shot yourself. So we need two numbers that will add to 13, but then multiply to whatever 6 times 6 is, because that's the value of A and that's the value of C. 6 times 6 is simply 36. So what two numbers satisfy this criteria? Well, this one might be a little bit more difficult, so let me write down all the factors of 36. We can see 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 is not a factor, 6 and 6, and those are all your factors. Well, I can see out of this combination, 9 plus 4 is simply equal to 36. Oh, sorry, 9 plus 4 is simply equal to 13, but 9 times 4 also equals to 36. So our solution of numbers are 4 and 9. So we're going to split the middle term, exactly like that. So what I'm going to write is I'm going to split the middle term as 6x squared plus 4x plus 9x plus 6 equals 0. And let's continue factorizing. We're going to group them up into groups of 2 as well. So from the first two terms, what we can recognize is we can factorize out a 2x. If we can factorize out a 2x from this first term, we're left with a 3 as well as an x. And from the second term, the 4x, we're left with a 2. Plus, what can we factorize out from 9x plus 6? Well, the common factor would be 3. We can factorize out a 3, and if we divide both these terms by 3, we'd be left with 3x plus 2. That equals to 0. Then we can factorize from both of these terms here, what's common? The 3x plus 2. So we're going to factorize out a 3x plus 2. 3x plus 2. And what are we left with from the first term and the second term? Well, we're left with a 2x as well as a plus 3. So in this case, 3x plus 2 can equals to 0, in which case x equals, we'll take it slow, we can do 3x equals to minus 2, in which case x is simply equal to minus 2 over 3. Or we can say 2x plus 3 equals to 0, in which case 2x equals to minus 3 and x equals to minus 3 over 2. So these are your two solutions for this non-monic quadratic, and that's how you use splitting the middle term.